Wonderful. So good morning. Thanks, Robert, for the quick intro. My name is Nick van Schoonhoven, and as the slide says, I'm going to be talking to you today about neutral data in our engineering configuration hub. Also, thanks, Ben, for the partial intro in your presentation. I appreciate it. So I'm the deputy lead of a group at Boeing called the Payloads, Methods, Processes, and Tools on the commercial side of the company. I've been with Boeing for 13 years, and I've worked on a bunch of payloads groups supporting the 737 and 787 programs. I've worked in teams like the Video Control Center, Stobins, emergency equipment, seats, certification. Eventually, I moved over to the knowledge-based engineering team. And then finally, doing similar job as with KBE, I went over to Payloads Core and now work in methods, processes, and tools. For the past 6 years or so, I've been the lead developer and project manager for an engineering data sharing application that's been really successful in reducing the engineering hours spent configuring airplanes to support our customer introduction process. And that's what I'm here to talk to you about today. Before I can do that, though, I need to explain a little bit about what exactly the payloads engineering function does at Boeing. I'll give just a brief overview of the payloads work statement and specifically what the pain points are with it. I'll then talk about the neutral data configuration hub, what it does, and how it helps alleviate those pain points. And I'll also talk a bit about the pain points that my team ran into when developing the tool and how we overcame them. All right, so what is payloads? Payloads includes all the stuff that a passenger or a flight attendant is likely to interact with on the airplane. So that's seats, overhead stow bins, galleys, closets, lavs, carpets, video monitors, reading lights, attendant seats, cabin video systems, all that stuff. It's also the stuff the passenger would interact with only on the worst day of their life, like life jackets or emergency equipment and oxygen masks and that kind of stuff. We call all of those different areas of concern commodities. And as you can imagine, there's a lot of points of contact between the different commodity teams. Within payloads, it's my group's purpose to ensure that the payloads commodity teams work as efficiently and effectively as possible internally, also with each other and also with the structures and systems organizations that are outside of payloads. For payloads, we have kind of two flavors of work. There's the first time new ground up designs, such as when Boeing creates a new airplane like the 787, or when they do a major refresh, like when they came up with the 737NG or the 37 MAX. This is the upfront work of defining what the contours of the ceilings or stow bins will look like, what sort of lighting we're gonna offer, or how many passenger seats abreast the airplane is gonna support, that kind of thing. There's plenty of upfront work to do for this, but in large part, that work is one and done. Once the overall shape of the interior is finalized, we don't go back and redesign the stuff for each customer. So one specific airline customer doesn't get a uniquely contoured shape for the overhead stow bins, for example. The second flavor of work is the ongoing repeated work for customer introductions. So the customer introduction process is how Boeing translates what a customer wants for their specific airplane interior into the final certified engineering for all of the physical parts that are installed on that one particular airplane. So this is the process where Boeing works with the airline customer to figure out what the mission of that airplane is going to fulfill. So does the customer want to have a lot of expensive business class passengers, or do they want to cram in as many economy class passengers onto the plane as they can? And then managing all the decisions that are related to that. So how many flight attendants do you need? How many galleys do you need? That kind of stuff. This work is done for every Boeing customer. And for many of the customers, there are different configurations for different sets of airplanes within their fleet. So obviously improvements made in the flow time and hours spent doing this kind of work are multiplied for every customer and every block of airplanes that we design. So it's a big hitter for lowering the cost of our airplanes and reducing the payback period for new airplane designs to become profitable. Most of the rest of what I'm going to talk about today is focused on this customer engineering work, or sorry, customer introduction work. So the biggest challenge Payloads faces is that we have many dozens of teams that interface with each other. And each of those teams have their own internal requirements and design constraints. All of those groups need to coordinate on unique installations for virtually every customer. And together with the large number of customer introductions we do every month, there are a lot of opportunities for things to be missed. The general problem boils down to how do we find the engineering and information if it exists? How do we create it if it doesn't? And then how do we retain it in a way where we can find it the next time so we don't have to design it again? It's really easy to miss all the customization that happens in payloads, even due to a fairly small customer change. So I'd like to walk you through a relatively simple example. Suppose a customer decides their maintenance crews would be able to reduce the time their airplane spends on the ground between flights by moving a galley just inside the passenger door, say an inch aft. So moving the galley means determining if the seat behind the galley now suffers from a passenger head strike issue. Maybe the galley change means moving the front row of seats aft an inch as well. The overhead stow bins also need to adjust to the galley change, which may be as trivial as swapping out an end cap, or it may require swapping out a bunch of bins to maximize the available stowage space. If you change the stow bins or the seats, then that in turn requires that the PSU team validates that the oxygen mask for that front row of seats drops in the allowable range for the front row passengers. The seat moving an inch aft, if they have to do that, means that there's now different wire lengths for connecting the in-seat video. And the cable raceways that protect those cables have to have their lengths changed, which affects how the carpets are going to be cut that go around that, so that the NC cutting machine at the end of the day makes the right sized part for the mechanic to stick down in final assembly. And even if none of those downstream changes turn out to be necessary, there still has to be analysis done to validate that the new design meets all the regulatory standards and engineering design rules. The whole process is additionally complicated by the fact that supplier data is not necessarily available when they're making this decision. And it's worth restating that these tiny differences exist for every single customer that Boeing has, and also between different blocks within each customer. And while this is a specific, or sorry, in this specific example, the overall process flow is, well, so even though this is a specific example, the overall process flow is the same for every customization. Engineering decisions and data are provided by an upstream team. That data is validated using constraints and design rules by receiving groups. Those commodity teams use their own internal processes to author their own design, and then relevant information from their design is passed on to further downstream teams. So in general, we have a few guidelines about how payloads engineering can be most effective. The guidelines are: we should only perform tasks that add value to our value stream and provide value to our customers. We should use the best-in-class tools to perform each necessary task as efficiently as possible. And we should rely on authoritative sources of data. So the first point is pretty self-explanatory. While automation is better and better processes and tools can make us more efficient at a task, nothing is as efficient as just not doing that task at all. For the second point, what we mean by best-in-class probably deserves some explanation. A best-in-class tool is one that performs a task as completely as possible, requiring the minimum of human input, and outputs the highest quality product that can be most easily consumed by any downstream processes. There's a lot of kind of fuzzy decision making that goes into deciding what constitutes a best-in-class tool, because the context matters a lot here. Is a nail gun or a hammer the best-in-class tool for driving nails? I mean, if you're framing a house, a nail gun might be the best-in-class tool for the job. But if you're hanging a picture frame on the wall, a framing nail gun isn't going to do you much good. Another consideration is whether you can avoid needing a second tool or process by choosing a different tool up front. For instance, maybe you don't need any tools to glue something together, but maybe using a screw means you don't have to use clamps or wait for the glue to dry. And those kind of distinctions are important. The last point here is that we want to use authoritative information sources for data and requirements. It seems obvious, but it has some important ramifications. The obvious part is that the data or requirements should be consumed directly rather than by copying it from one tool to another. This prevents the copied data from becoming stale, or meaning that the downstream tool has a wrong value because the source value was updated and the downstream tool never got the message. Actually doing this, though, requires that the information source is able to provide it in a way that the downstream tools can consume. This means that the format of the data and the structure of the data needs to be machine readable, and ideally, we want the data to be both machine readable and human readable, so it can be easily audited and checked. Also implicit in this guideline is that the systems or people that are affected by a change have to be notified either automatically or through a person in between when the upstream data changes. Going back to that second point about the best-in-class tools, choosing the best-in-class tool for a data application includes whether or not it can pull authoritative data from upstream sources and provide it to downstream processes. So it's a big part of that. There seem to be two kind of competing schools of thought regarding how managing data should be accomplished. The first is to have all the data, or at least as much as possible, on one platform that can provide all the user interfaces required to interact with it. So Dassault's 3DX product is in this camp. The 3D Experience platform is intended to handle the entire value stream, including requirements gathering, sales support, CAD, bill of materials, BOM management, and all that. The Dassault team created a product that is kind of out of the box capable of covering a large swath of the design and engineering space's technical needs. And 3DX might be the right fit for a company, regardless of if it builds, say, plastic toys or phone cases, or if it builds diesel engines or cars. The trade-off is everyone you do business with needs to provide data that is compatible with that one product, no matter what their system does. And this can be fine if one company dominates the market. I mean, it's easy to find a program that works with Microsoft Windows because Windows dominates the consumer PC marketplace. But you can be left vulnerable to vendor lock-in, which means if you author something on 3DX, you might not be able to use it in some external system unless you have access to their licensed platform to access it. The second school of thought is to use a specific product to manage a particular aspect of the business and try to pipe data from that system into and out of others. So PaceLab, for example, created the sort of de facto standard for designing aircraft interiors. So their product handles option catalogs and selectable characteristics and plan view diagrams and 3D renderings of the cabin that the customer can use to figure out what kind of airplane they want. You can't use PaceLab Cabin to design a plastic toy or diesel engine, but it's the best application for configuring an aircraft interior that we have out there. The downside is that you need to have or build mechanisms to pass data from these single-use applications to other applications that need that data. And that's not necessarily always easy. And it's worth saying that these options aren't mutually exclusive. I mean, you can use Dassault products for CAD and BOM, for instance, and have an entirely separate system for accounting and supplier data transmittal. In Boeing's case, there are operations which Boeing needs to perform that are outside the scope of what any supplier's products can do for us out of the box. In some cases, the reasons for this are the proprietary secret nature of the techniques we use in our design and manufacturing processes. But in other cases, there are best-in-class applications that are outside of that particular tool suite that we want to be able to take advantage of. So what would a best-in-class tool for managing customer introduction data look like? Well, it would need to have an intuitive user interface to minimize our training costs. This goes back to what Ben was saying about joy. Nobody wants to have to learn a complicated esoteric system if they could instead use something that is simple and obvious to use. The tool would need to make it easy to do things right and easy to tell when they're not right. It would need to be customizable to handle the arbitrary data that design teams care about. It would need to automate the administrivia, and it would need to output human readable information for design validation. It would also need to handle all data of all kinds for the entire value stream, or it would need to be able to pipe machine readable data back and forth to outside tools. And our current best-in-class tool for handling this kind of information is our configuration hub. So within Boeing, we kind of recognize that commercial airplanes are complex and unique enough that no supplier out-of-the-box application would be able to provide us a mechanism to handle all the specific data and process flow that our business requires. Instead, we created a custom web-based engineering configuration hub to facilitate the communication of engineering intent between all of the interfacing commodity teams as efficiently as we can. The hub is able to store information about each airplane design, and we can apply design rules to automate the individual commodity team's internal processes. So any information we put into the tool is available to any other commodity in the hub, and it's also made available to outside applications via a web service. So to go back to the scenario we had about moving the galley aft an inch, with our configuration hub, the galleys guy updates the galley location in the tool, and the hub automatically notifies the seats and stow bins teams that of exactly what that change is with a graphical layout showing the full configuration, but it also highlights the particular change that was made. The seats team then can validate the head path using functionality built into the tool. And the stow bins team can repitch the overhead bins using automated functionality in the tool, an auto-generate button. And the hub will find any existing engineering that already exists for their commodity, letting us reuse existing data and the engineering definition that goes along with it. The PSU team is then sent a highlighted graphical layout showing exactly what changed, specifically for the stow bins and the seats, so they can go into the hub and update their engineering as well. Again, we have auto-generate buttons and interface checks that show exactly which things need to change and by how much. The same sorts of things go for the wiring, cable raceways, and carpet teams. To circle back on the 3 guidelines we had for the good application about only do what needs doing, use the best-in-class tools, and use authoritative data, when we were defining each commodity team's inputs and outputs for the configuration hub, we took the time to ensure that each team is only performing the tasks that actually add value to their downstream customers. There were plenty of cases where a team would create a layout that had all the information that their team needed internally, but a lot of that information wasn't necessary to downstream teams, and it sort of obscured where the changes were or what the things were that mattered to those downstream teams. So by going through this process, we're able to create specific outputs for the guys who need it, rather than having one output for the entire commodity. Since the configuration hub is able to perform a lot of automation activities based on the data that's available in it, it saves a ton of engineering time, which for us puts it firmly in that best-in-class category. And at each step, the data is authored only once, and the team that's responsible, by the team that's responsible for defining it. And then any team that needs it downstream is able to just use it. So we can definitely use that authoritative data. This particular example doesn't cover the full breadth of the functionality that we get from the configuration hub. We've hooked the hub into our option selection catalog, which lets us drive engineering decisions directly from the customer selections. We've tied it to our bill of material systems to let us identify existing engineering and define work statements when we need to create new engineering definition. We've created interfaces in the hub that allow us to catalog and track supplier data and testing results, which we use as part of our airplane certification process. And at every stage, the configuration hub acts as a value multiplier for our engineering teams to help them be more efficient and effective. Our configuration hub, just like any application that's not part of a larger tool suite, has to be able to seamlessly consume data from outside systems, and both on the input and on the output side. So we rely on APIs and database connections that are available for those outside applications. And this availability of data allows all the information required for making engineering decisions to be easily consumed and acted on by the design teams. It also allows us to better reuse the engineering when a portion of a design from one customer meets the needs of another. One critical point here is that we rely on the APIs of downstream systems to allow us to set attributes based on updates in our tool. So if a design change requires a name update in a part in CATIA, for instance, we want to be able to update that part number without having to manually rekey it into another application. And those APIs on the CATIA side allow us to do that. A large part of the data that our hub feeds into the value stream is in the form of human readable coordination documents. These documents describe in detail the conceptual design for each commodity. So from our galley team, we have a document that describes the galley location, but it also includes information about where the water and power disconnects are. A separate document for the Stobin team shows the sizes and positions of the overhead bins. A seat document shows the seat location and the crash test head pads. And the PSU document will show where the oxygen mask will deploy and where the no smoking fasten seatbelt signs are going to be located, information like that. Since all the information is available as data to the configuration hub, we're able to automatically flag problems in the current design. We're also able to graphically show differences between iterations, so between the original state and the new state that the customer is asking for. This makes it easy for the downstream teams to know exactly what changed and react to it. Letting our configuration hub create our coordination documents has created a kind of subtle difference in the way that we consider our data. Without the configuration hub, the coordination document was the authority for certain information. The galley goes here because the galley coordination document says that it goes right here. With the configuration hub, though, the data in the hub is the authority, and the coordination document is just a view of that data. On Tuesday, a guy from Northrop, Dr. Jay Simmons, noted that he said in his presentation that documents are not dead, they're artifacts of the state of the data. And our data hub absolutely implements that kind of idea. The data hub is an artifacts generation engine, if you like. But just because we create coordination documents, doesn't mean that we don't output data to other applications directly. So we feed parametric data regarding, say, volumetric envelopes for seats into CATIA models, defining new parts that we can use for fit check purposes. We do similar things for a lot of repetitive actions for other commodity teams. So for instance, those cable raceways that are installed next to the seat tracks, the lengths of those raceways is entirely determined by the spacing between seats. And since the seat spacings and raceway part numbers are available to the configuration hub, we're able to instantiate several hundred of these parts into our 3D assemblies and BOM system automatically. The result is a fully annotated installation drawing and CAD representation of all these raceways for the plane, which saves countless hours of really mind-numbing work for the engineering teams. It also completely eliminates the human error element of it, where you have to calculate part lengths, determine what part number has that length, determining how many of each of those part numbers you have, and then sticking them into the 3D model at the right location. So going back to what Ben was saying, that is a huge joy element of not having to do really tedious work. By far, the biggest enabler for all this automation is our use of neutral data. So when I say neutral data, what I mean is that it's data that can be consumed and interpreted from systems outside of the one that created it. So an XML file can contain data that can be consumed by any application. But a measurement taken interactively in CATIA by inspecting elements within a model is maybe less accessible. By forcing our critical design attributes to be managed in a neutral data format, we're able to parse them into numerous systems for our analysis and design work. So our configuration hub passes data in and out using JavaScript object notation. And well, JSON is the shorthand of that. And our web service can feed that information to any automation or application within Boeing. And I'm sure it'll shock no one here that engineers love data. One positive but kind of unexpected effect of our data hub has been that some of our engineering teams have run with the idea, and they've created their own automation tools specific to their commodity using data from the hub. Coordination and commodity attributes are entered and retained in the hub, so the teams can just pull that information and use it for their own automation. The commodity teams benefited a lot from the process of encoding their rules into a consistent enough form to be used in our configuration hub. And that has naturally increased the sort of consistency and quality of their designs. I mean, it's pretty easy to set all the attributes on a part when they're set automatically by a tool for you. And it's turned out that engineering teams creating tools for themselves to do the work that their team knows how to do best has turned out to be faster and cheaper than a lot of the traditional engineering IT relationships that we've had. And it's resulted in a higher quality product in less time. And it's contributed a lot to the reduction in time that Ben alluded to in his presentation just before mine. So one thing that's a little hard for design teams to handle is making the transition from their siloed data into a more available data form. So it's pretty easy and natural for a design team to create a spreadsheet to track some attribute that they care about, or some set of attributes that relate to their design. So, I mean, someone creates a quick reference document for themselves, and then before you know it, it's a shared document on a SharePoint with 20 engineers in the team that are updating and referring to it to look up some piece of information that's only tracked in that one spreadsheet. It's basically data suicide, but with more steps, right? Siloed data contradicts our use authoritative data rule, as it can't be accessed directly by anything else that needs it. And often it can't be relied on because it's fraught with all the problems that you'd expect. So human error on entry, it's not checked by anybody, and who knows how old that data is and if it's still legit. So for many groups where we pulled their data from their siloed locations into our configuration hub, it made the data, not just made the data available to downstream teams, but it also improved the quality of that data. So a few of the lessons that we learned. Wherever possible, we tried to provide benefit to the commodity teams that we were working with directly. So either by auto-generating attributes based on their rule sets, or through automatic pulling of data from upstream data sources. But some teams didn't benefit directly. Especially in the beginning when we didn't have such a large base of data to draw on. The question we were often asked was, why use a customized application to create something that I can create just as fast in Visio? And in Visio, I can have more control of it and I can make it look however I like. And it's a fair question at the group level, but at the system level, by having a group provide data in the data hub, it lets other teams not have to duplicate that data someplace else. It can be a hard sell if the commodity team is graded based on just their silo's performance rather than by the overall system performance. And in a few cases, we had to get higher management involved to either sponsor use of our app or to provide visibility of what the benefits were at the system level to bring certain commodity teams on board. I'm confident at this point, though, in saying that between the automation, the consistency of the resulting data, and the functionality to highlight differences between design iterations, that every commodity that's using our configuration hub is getting direct benefit out of it now. And the benefit is just compounded even further at the system level. We have a process in Boeing for virtually every task that engineering performs. And engineers are also often the very first people to ask the question, why should I follow this process? And if they're not given a satisfactory answer, then they'll sometimes neglect to follow that process. So usually the answer of, we do it this way because then the computer can do it for us, is compelling enough for most engineers to work out how to adjust their processes to do things consistently every time. Small things like using a consistent naming convention, for example, for parts in Enovia, can enable a huge time savings by letting the automation find existing BOM definition, rather than having to manually dig through hundreds or thousands of installation drawings. The next lesson we hit was that perfect should never be the enemy of good. We had a few cases when working with commodity teams where we would show that we could automate 70 or 80% of the work that they had to manually do. And then we were met with resistance because some manual effort at the end was still required. Like we would automate the creation of a installation drawing showing where all part numbers for a specific commodity were going to go. But then they would have to manually move some of those part numbers around because the part number was too long, and graphically looking at the drawing, they would overlap. Small problems like that, but still required manual effort. As the developer of something that's doing automation that is meant to save time, it was incredibly frustrating that you could remove 70% of the work statement and people are still upset that they still have to do the last 30%. I mean, let's face it, taking out that 70% would mean that you have 70% less time doing administrivia and 70% more time that you can spend solving actual engineering problems and actually adding value to the product. I guess lastly, the sales pitch matters. So if I walked up to you and I said, I want you to help me automate 70% of your job, you would probably not be particularly motivated to help me develop that kind of automation. If on the other hand, I say, I'd like you to tell me what is the least fun part of your job so you don't have to do it anymore, then you'd probably have that list of tasks to me, on my desk before I could finish my sentence, right? I mean, everyone has parts of their job they don't want. And if we can automate them, then just like Ben said, we can increase the joy that employees have every day when they go to work. Let's face it, nobody goes to engineering school and dreams of graduating one day and then spending the next 30 years filling out spreadsheets and doing paperwork and counting fasteners and drawings, right? We become engineers to solve problems, and specifically interesting problems. And since there's no shortage of problems, if we can automate the boring stuff, then we can use our imaginations and time to come up with the next new innovation. So a few final thoughts. If I were to describe the perfect scenario for payloads so far as data interoperability is concerned, it would have these kind of attributes. So we would want seamless data exchange between applications and domains through the entire value stream, from conceptual definition to aircraft retirement. So any piece of information authored or received by anyone in the company would be immediately available for any required task. Authoring or receiving data would be done in using a best-in-class application for every task that we need to accomplish. And any piece of data that can be manually entered, we want to be able to set programmatically. We don't want to use engineering time manually interacting with the tool when the values we're entering come from someplace else. Neutral data in our configuration hub is a nice big step in this direction. So thanks very much for your time. I appreciate you giving me the opportunity to share a bit about payloads at Boeing and how our data hub has been a value multiplier within our company. And this is the end of what I've got for you today. So are there any questions I can answer for anyone?
Yes, we have one in the question panel, actually two. We have about 12 minutes remaining. So let's start off with the first question. If a design is machine readable, why can't it be machine audited instead of human audited, eliminating the need for human involvement?
That's a great question. And in a lot of cases, it can be machine audited, but an audit is only as good as it is programmed to be when it's machine done. So absolutely, we want to automatically check to make sure that we're not installing two PSUs at the same location, or that all of the oxygen mask drops are in the right place. But at the end of the day, it's a person who's sitting in a seat whose life depends on it. So we want to have eyeballs on it to make sure that some strange configuration of things didn't result in something going haywire. So absolutely, we want to use automation to audit stuff, but we still want human eyeballs in the loop.
Okay, thank you. Another question from Brian. Is the configuration hub a homegrown application or a part of the Dassault 3DX platform, CATIA, Innovia, et cetera?
Yeah,
Do you
great question.
leverage, second part, do you leverage Systems Modeler for MBSE and linking requirements to modeling and analysis, key artifacts, et cetera?
So great question. Our configuration hub is not created by Dassault. It's homegrown specifically for Boeing's payloads workflow. It does have tie-ins to, well, currently it has tie-ins to our V5 CATIA and Innovia. And once we have more guidance on when Payloads is going to make the switch over to using 3DX, we will, I'm 100% positive, have hooks into that system instead of what we're currently doing. We don't currently have hooks into Systems Modeler, for instance, but again, it's all dependent on when Payloads within Boeing makes the switch over to 3DX, so that we can have budget and funding and time and all the rest to allocate towards that. Did I answer all parts of that question? I think I did.
All right. Okay. John asks, is DS aware of the data hub to possibly make it commercially available in some form?
This is a question where I have to defer a bit because I don't want to give away trade secrety stuff. I don't think that Dassault is specifically aware of our configuration hub in its final state. And I don't know that we would want to share it with our competitors even if we could. So I think it kind of, the on the ground implementation of it is kind of on the trade secret side, and we don't really want to share that.
Okay. We have another question, and we've got just a few minutes left. Or have we gone over yet?
You still have about 8 minutes.
8 minutes. Okay, I'm sorry. The system looks like it was created by design engineering. Usually tools like this are created by a central IT organization. How has the Boeing IT team reacted to this system?
That's a great question. Positively is the short answer. Boeing's IT is constrained by a number of business rules, and they want to do a lot more than they have the capacity to support. So by having this be an engineering application maintained by engineers, that's effectively work that they don't have to do. At the rubber meets the road, this design team needs to do this particular thing and click this particular button level. But we do have support from IT for things like our database side and our website administration. And that's stuff that IT has both the technical expertise that is required as well as the capacity to support. So we haven't had any pushback from IT saying this should be ours. The only things we've gotten have been, how can we hook our system up into other IT systems? And they've been positive and supportive on that front too.
On a sidebar, does engineering support it, or do you try to get IT support when you have issues with the system?
Engineering supports it. We are paid for by the 3 primary commercial airplane programs. So 787, 777, and 37.
Okay, we've got 3 more questions in the hopper that keep rolling in. How do you go about getting buy-in from the various constituencies you're trying to help?
Another great question. Sometimes it comes from giving a roadshow or having a presentation available within our Boeing online system. insight, it's called. So sometimes groups just seeing what is available lets them say, hey, this would help my group. And then usually we have a meeting with the actual person sitting in the chair doing the engineering work for the commodity team, and they say, this is the kind of stuff we do, and we provide feedback as to what we can help with and what information we can feed to them from other commodity teams. We have our own limited constraints on how many people we have working, so we look to the engineering people specifically to say this is how much bang for the buck, or how much bang I would get, and we look at the our own sort of process for onboarding commodity teams, say this is how much it would cost, and then we prioritize which group would get in when based off of that kind of information. We've had very good support from all levels of management, really, with being able to provide, or with being able to direct developer resources towards onboarding commodities. So usually it's just a discussion of what do we need to do first to enable stuff. So it all starts with just conversations with commodity teams to get them rolling. And we get a lot of word of mouth where maybe a 3.7 seats person talks to a 777 seats person and says, hey, we're doing our process like this and it's helped. Then the other team is able to say, hey, that would be nice to be able to eliminate this, that, and the other. So we get a fair amount of just crosstalk between commodity teams saying we like or don't like this or that.
Okay. Alex has asked, can you provide an estimate for how much Boeing saves by using this data hub?
A lot. I don't know if I'm allowed to share the actual dollar number.
Okay, that's fair. When you talk about savings money, it's costing you to support it, right?
Mm-hmm.
So is that factored in as far as what you actually save?
Absolutely, it's factored in.
Okay.
The person who asked the question, if you want to email me directly, I can get permission, if possible, from the people I would get permission from to share that with you, and I can give you actual numbers. But it is many orders of magnitude in savings what we spend on creating it.
Okay. And another question, what software tools were used to develop the hub? Database engine, UI tools, translators, etc.
Yeah, so the vast majority of the code was written in JavaScript, and we used Visual Studio 2019 Developer Edition, I guess, to code that. So I think the numbers are something like 75% of the code is JavaScript. There's about 20% that is C# for our web service, also in Visual Studio. And we have a SQL Server, Microsoft SQL Server backend that we manage using SQL Server Management Studio. Yeah, I think that's it. Oh, sorry. We also have written a few Python utilities that just handle some data conversion stuff. These are sort of the one-off things where, let's say we have a drawing that say the ceiling panels team has made that shows the shapes of their panels, and we want to import those to use them in our web tool. So we have to translate it from, say, a cat drawing into SVG paths or something like that. And we write those little utilities in Python.
All right. Looking. I don't see any more questions in the chat or the question panel. So want to thank you, Nick, for the fine talk and sharing what you could share, and respecting your privacy as far as what you cannot share. So we appreciate you pointing that out. So if there any other, go ahead.
I was just going to say, if anybody has any specific questions that I wasn't able to answer with specific answers, then send me an email and I can get permission, and I'll respond back, I promise.
Okay. Any other follow-on comments? All right, so at this point, we'll close this session, and we will put up a shot of the agenda. So if anyone comes in while we're out on break, because this is a break time right now, they will see that we will resume in about 12 minutes.